Let's say that I wanted to find the slope of a point somewhere on a curved line. When it's a nonlinear function, we can't use the formula for slope, which is the change in y over the change in x. In order to do that, I need 2 points. So if I picked a second point up here, I would be actually looking here at this secant that goes through the 2 points. The secant line is only an approximation. And if I was to pick a point that was a little closer, say here, and I found the tangent line while using the secant line, you'll notice that as the point gets closer and closer and closer, it will approach the slope of the tangent line, but these secant lines are just approximations. The way we find the slope on a linear function is to locate a value for the x and another value for an x. There's 2 points. Well, the x2 point, this one over here, it changes by some distance from the original x, and we'll call that delta x. And delta just simply means change. And then talking about the y coordinate, the original x, this y coordinate, y equals f of x, so I'm just going to call that f of x over here. And then for this one, this is the x number plus delta x to give me the x coordinate. And since this is x plus delta x, well, then this over here would be f of x plus delta x. Now I have an x and a y for each of these points. So let's plug those in. The change in y is found by having the y2 point, which is f of x plus delta x. And I would subtract from that the original y, which is just f of x. And then for the change in x, well, the change in x is just the different distance between these 2 points, which is delta x. And we'll just bring down delta x from the original formula. We're just about there. All we would need to do is plug these in. But what we're going to do is we're going to use the limit process, because if I was to actually bring this point down, if I brought this point down and keep getting infinitely closer to this, it would be x minus x, so this would be 0. And the same thing would happen here. Both of these values would be 0 because the point isn't separated. I would get an indeterminate form of 0 over 0. Well, we can use the limit process to find the slope at this point. Setting up our limit, finding the first derivative of x is going to equal the limit as delta x approaches 0 of f of x plus delta x, which is our y2 point, minus f of x, which is our y1 point. And then for the change in y, we're just going to leave it as delta x. Now we're going to pick an f of x, so our function is going to be x squared. And our f of x plus delta x, we replace the x by x plus delta x, just as if this was f of 2 would be 2 squared, f of 5 would be 5 squared. So f of x plus delta x is x plus delta x squared. I'm going to distribute this using FOILs, so we're going to get x squared plus 2x delta x plus delta x squared. Now we'll go back to the original formula and substitute. Until you actually substitute the 0 for delta x, you have to keep bringing down the limit notation. I have delta x approaches 0. So now we'll substitute in the numerator. I have f of x plus delta x is x squared plus 2x delta x plus delta x squared. That's my y2 point, and I'm going to subtract my y1 point, which is f of x is just x squared. And that whole thing b over delta x. I still can't substitute 0 in for delta x. I need to simplify this first. So limit as delta x approaches 0. Now x squared minus x squared, they add up to 0. And then what I have is 2x delta x plus delta x squared over delta x. I can factor out a delta x from both of the terms in the numerator. So I have limit. I'm going to take out delta x. Remaining inside would be 2x plus delta x over delta x. Now this is the part of the algebra that simplifies it, that will allow us to apply the 0 in the limit. Delta x goes into itself once, both cases. Then I have the limit as delta x approaches 0. And the only thing that's left is 2x, because I have 2x plus 0. So then f prime of x, when delta x does become 0, this falls out, leaving 2x as my answer. So this is the derivative of x squared. So let's try one that's got two terms in it here. So my f of x is going to be x cubed plus 2x on this next example. So we need to find f of x plus delta x. And again, we just substitute x plus delta x in place of these two x's. So what we get is x plus delta x cubed plus 2 times x plus delta x. We'll work on this numerator over here. So we need to find f of x plus delta x minus f of x. And what I'm going to do is, when I bring this down, I'm going to write this whole thing in expanded form. So this is x plus delta x times x plus delta x times x plus delta x. And then I have plus 2 x plus delta x. And that whole thing is just the f of x plus delta x, which is this in expanded form. So I took this whole thing and wrote it expanded. And now I have to subtract the original function, which is x cubed plus 2x. When I do FOIL, I'm going to get 2x delta x plus delta x squared. I bring down everything else I didn't use. I'm going to distribute here. And I'm subtracting here, so distributing the trinomial to the binomial. Then bring down what I didn't use. Next, I'm going to simplify because there's some terms like x cubed minus x cubed minus 2x and plus 2x fall out. I'm going to combine these two terms. Combine these two terms. And bring down everything else I didn't use. Next, I notice that all these terms have an x, delta x in them, so I'm going to factor out the delta x. I get 3x squared plus 3x delta x plus delta x squared plus 2. So this whole thing here is going to become the numerator in the formula. So let me clean this up. So now with the simplified numerator plugged in, and I notice that I can just simplify here. Well, it goes in one time for each of those. So the revised limit Well, now as delta x approaches 0, this term is going to fall out because that's going to be a 0, and this term is going to fall out because that's going to be a 0. So the finalized limit f prime of x would be 3x squared plus 2. In this problem, we're given the function of x is going to be 1 over x, and we're asked to find the slope at 1 comma 1. So our f of x plus delta x be 1 over, and then our f of x plus delta x minus f of x going to equal 1 over x plus delta x minus 1 over x. And we'll go plug this back into the. When you get a fraction like this, what you're going to do is you're going to multiply by what the denominators are. We're allowed to multiply anything by 1 and still get the same thing back. But instead of the 1 here, what I'm going to do is I'm going to multiply the top and bottom by it'll be the same numerator and denominator, and I'm going to get a common denominator. So I would just multiply these two together. If it was a 3 and a 4, I would just multiply 12 over 12. So I'm going to have x times x plus delta x over x times x plus delta x. So this is still a 1. And now I'm going to multiply. Now, when I multiply this fraction times this numerator, which would be over 1, what would happen is, I'll just write it out so it's clear for the first one. So this would go into itself once and into here once. So this whole thing over here would be replaced by just simply an x. And then the same thing would happen over here. So this x goes into itself once and into this one. So this one would be replaced by this. We have the limit as x approaches, delta x approaches 0. And then this one gets replaced by just an x. And this one gets replaced by the x plus delta x. This whole thing in the denominator, when I multiply this, simplifying on the next line, I'm going to distribute. Now x minus x, that's going to be 0. Have negative delta x on the top. And in the denominator, I have delta x. So it goes into here once, goes into here once. So I'm now going to have a limit. That's delta x 0 of minus 1. Just this last step. I'm going to distribute. When delta x gets to 0, this term falls out. So our derivative, f prime of x, is minus 1 over x squared. And the final step, it wanted us to find the slope at 1 comma 1. So I'm going to substitute in the x over here. Well, I would have 1 over 1 squared, which is 1. So the slope is minus 1.